Once you get there. The supernatural, everything is possible. What's happening now?
So good morning, class.
Hello.
I'm sorry for coming in 4 minutes.
Good morning, ma.
I hope we are doing very well. I hope we submitted our classwork very well. Yes. I also want to make an announcement here that whenever I give you assignment, you don't need to go on Google to look for the solution to the assignment. Because if you do, I will know and I will use it against you. Hey. The assignment is for you to go back to the slides and study the slides, because the answer to every assignment is in the slides. So anybody that go up for AI or go for Google for solution to the assignment, I'm going to use it against you. Please, your assignment is meant to be sorted on using your slides going forward. So somebody was asking a question yesterday that he didn't understand this particular slide where we are talking about the mechanism of electrophilic aromatic substitution reaction. So I want to see if I can simplify it as much as I can, because it's something that would have been better done on board. Yeah, I'll be writing, I'll be explaining. But now let's do it this way. Please, I want this class to be noiseless. I don't want interruption. We just have 1 hour. So please, everybody should mute their mic. Everybody should mute their mic. Everybody should mute their mic. As soon as you're entering, if you understand, when I came on, I muted myself. So whenever you come on any online meeting, whether class or anything, the first thing you should do as a learned person is to mute yourself, except you are a speaker, so that you don't go there and people start saying, who is this? When people start talking, telling you to mute your mic, it means that you don't know how to use your handle, and it's not a good news for you. So please, everybody should always learn to mute themselves. Is Eniola Grace, Eniola Smile?
I said 5 minutes, please.
Apollonia, Eniola, is it the course rep for chemistry?
No, ma.
Yes. Who is the course rep for chemistry? Unmute and talk if you're here.
I don't understand. Was that like
who is course rep for engineering? Who is course rep for engineering? Isaiah. Eyang. Ifo Alabe. Ife Olua. You should mute yourself. Akisonya, mute yourself. Mute yourself. Who is Akisonya? Is there any course rep that is in class this morning? Any departmental course rep that is in class this morning?
MIC, ma.
Okay, what's your name? You're muted, right? Are you?
Yes, ma.
Okay. Are they Angie, right?
Yes, ma.
Okay. So you're going to help me manage the class today. Make sure that everybody is muted.
Okay.
Thank you very much. Okay, so let's continue the class. Now, whenever you're given a benzene ring, this is benzene ring. The person that asked the question, I hope he's in class. Now, when I told you that a bond is made up of positive and negative charges, right? So now, look at this electrophile coming in is a positive charge. When you break any of the bonds, you're going to have negative and positive centers. So this positive center is going to come and bond with negative center and leave positive centers. That's what we have here. Neglect the hydrogen. This hydrogen. So the hydrogen is telling you that there is hydrogen remember, benzene is made up of C6H6, telling you that the hydrogen there is still there, is not missing. So then because this electrophile is coming to bond and there is hydrogen in that carbon, that's why we are seeing hydrogen and electrophile, telling you that a bond is made up, because it's unsaturated, we have only one hydrogen. But when it's saturated, it's supposed to have two hydrogen. But because the bond is broken, it's like all the two hydrogen is there. So that's why one of the hydrogen is like, because of that broken bond, is now the electrophile. So a bond is broken. When there is no bond, we have a cyclo compound. In that cyclo compound, it is two hydrogen. But because it is aromatic, we have one hydrogen. So now, when the bond is broken, we have positive and negative center. The negative center is where the electrophile is coming to bond, then leaving the positive center. So that is the positive center we have. So this positive center is what we have to be moving towards in this particular slide. You're moving towards that positive center because you want to create another negative nucleophilic center so that's to form another bond. Electrophilic and electrophilic center, that are positive and negative centers, create a new bond. So that is why we realize that in the canonical form 1, we are moving towards that positive center created by the electrophile attack. So now when we do that, we are also behind it is going to create another positive center, because where a bond is moving away from is creating positive, where it's moving towards is creating negative. So what we are doing is that we are going to be creating positive center and forming new bonds. So that's what we're going to do until there is no other bond to break to form a negative center. That's what we have in canonical structure 3. Where there is positive center, there's no other bond to break to create another new bond. So in that case, what will happen is that hydrogen is going to leave. When it leaves, it's going to break in. The bond of hydrogen is going to break in so as to create a negative center that will form a new bond. And that is the new bond we formed in this particular slide, where the hydrogen moves and the electrophile is standing alone. This can only occur in the presence of a nucleophile. A nucleophile is a negative species that need a positive species to stabilize. So that is why we have this as a fast stage. All these ones are one that happens slow. So whenever you're talking about mechanism is 2 steps, the slow step and the fast step. So that is what happened. Now, in the normal reaction, in a normal reaction, if you're talking about the reactions of benzene or aromatic compounds, where you're not expected to tell us the mechanism, you're just telling us that electrophile will come and attack in the presence of a catalyst, and we are going to form the products. So the mechanism is telling you, is showing us the step for the reaction to occur and for the product to be formed. I hope you can still hear me.
Yes,
okay, fine. So now
yes, ma'am.
Okay, now in the spirit of the mechanism, remember 2 things are working in mechanism. Number 1, we've shown how benzene is going to react when you're talking about mechanism. Now, in a typical example is nitration of benzene. Now, nitration of benzene in the sense that we are going to first of all generate the electrophile. Remember, the electrophile that is represented by E. We are going to generate it before the electrophile does the attack. But for your 213, a person can come and say, which of the following is a correct reaction for generation of electrophile in nitration reaction? Now, in nitration reaction, we are using NO2 positive as our electrophile. So whenever the first step, whenever you're doing
mechanism of nitration of benzene is to generate the electrophile before the electrophile attack. In that case, you're going to have 3 steps. For mechanism of benzene, we have 2 steps because we're talking about slow and fast. But because electrophile is coming, we have to talk about how do we generate this electrophile. That's the mechanism. Now, in a normal reaction of nitration of benzene, we are going to see for any electrophile to be generated, because we are trying to protect the aromaticity of benzene, we need a catalyst so that the double bond will not be attacked. So that's why we are using sulfuric acid as a catalyst for generation of electrophile, which is NO2. So in nitration reaction, you need nitric acid and sulfuric acid. Listen, when you're dealing with benzene, nitration of benzene, you need conc nitric acid and conc sulfuric acid, because benzene is not very activating. So we need conc of it for the reaction to be occur. So we're going to go, when we talk about some other aromatic compounds, there are ones we don't need conc. But for benzene, we need conc. So this is what confuses students in exam. Because it's CBT, they can tell you which of the following are reagents for nitration of benzene. They will put nitric acid and sulfuric acid. They will put conc nitric acid and sulfuric acid. They can also put conc nitric acid and conc sulfuric acid. But if you're not, and they can also put maybe nitric acid and HCl. But if you're not very thorough, you can just go and put nitric acid and sulfuric acid without considering the conc. If both of them are not in concentrated nature, it cannot work for benzene, but can work for any other derivative of benzene that is activating. We are going to see in the subsequent slide. So note it very well. So for my nitration of benzene, I need it to be conc, both nitric acid and sulfuric acid. Sulfuric acid is a catalyst that helps for generation of NO2, which is the electrophile we are looking for. So the reaction simply means nitric acid plus sulfuric acid is going to form NO2 plus ozonium and HSO4 minus. Now, that HSO4 minus is the sulfuric acid that is going to come and attack, is the nucleophile that is going to come and attack the hydrogen to be regenerated. Remember, a catalyst is that substance that will speed up a reaction, but at the end is regenerated. So this is a sulfuric acid. So in generation of electrophile, it's going to lose a hydrogen ion, right? So when the reaction is completing, it's going to abstract that hydrogen ion from benzene to stabilize itself. So that's how the reaction occurs. Every other thing is what happens that we talk about in nitration of benzene. So what you need to know in this place is how to generate the electrophile, which we are going to attach as E in the reaction that we just talked about, mechanism of benzene. Mechanism of benzene that we just talked about. So that electrophile is NO2 here, when you're talking about nitration. So every other thing is the same thing. The nucleophile is that HSO4 minus, which is sulfuric acid that is not very stabilized, because the nucleophile is going to take hydrogen to itself to stabilize itself and is regenerated as a catalyst. So let's continue. Now, in sulfonation of benzene, now in all these things, everything is still the same thing. The only thing is that the electrophile we are needing, we need to regenerate it. The mechanism is still the same thing. Now, sulfonation is a reversible reaction. Now, strong acid is involved. In that case, we need conc sulfuric acid. That conc sulfuric acid is going to generate our electrophile, which is sulfonic acid, SO3H. So in sulfonation of benzene, the electrophile is SO3H. And we're going to use conc. Okay? It is favored in strong acid. So we need strong acid. Why the sulfonation is favored by dilute acid. So when we are going to talk about their typical reaction, you're going to see how the reaction is being presented in terms of their reagents and the catalyst. So sulfonation is sulfonic acid that is added. And remember, if you look at when we are talking about nitration of benzene, you realize that we have electrophile and hydrogen in slow stage. So when we are going to fast stage, HSO4 minus is still the same thing that is going to come and take that hydrogen to regenerate as a catalyst. So the catalyst you're going to use in sulfonation is still sulfuric acid. Okay, so we're going to see it in subsequent reactions. So sulfonation, sulfonic acid. So we're going to use conch sulfuric acid and the catalyst and the reagent are the same. So that's why you see them putting 2 mole of sulfuric acid and they're supposed to be in conch form. Let's continue. Then we come to halogenation. In halogenation reaction, all halogenation reaction, we need a catalyst. Unlike when you're doing halogenation in alkene, you don't need a catalyst or alkyne. But in this halogenation, because in that one, in those halogenation is addition reaction. But this halogenation is substitution reaction. That's why we need a catalyst so that the double bond will not be affected. In that case, if I'm brominating, I'm going to use bromine molecule with iron 3 bromide. If I'm chlorinating, I'm going to use chlorine molecule and iron 3 chloride. If I'm doing iodination, I'm going to use iodine molecule and iron 3 iodide. Please understand that because in the exam, these are some of the mistakes people make. You will not look very well. They can write Fe3 Br and Br2. They can also write Br3 and Fe Br3. So some of these things are confusing. So if you don't understand it very well, you're going to pick the wrong choice. Why CBT is very, very dicey is that whenever, even if you know it and you did not look well and you make mistake, the computer will not tell it because you make mistake. So that's why you have to be thorough. Whenever you're going for your CBT, wear double lens and take your time. Don't rush. Don't be feel that I have read it, I've solved the question. So you're choosing the option that look like it. So be thorough. So in bromination reaction, like we did in others, bromine molecule in the presence of iron 3 bromide. Now, the electrophile is bromine. Just flashback at the previous slides where we have electrophile and hydrogen. So that electrophile is bromine and hydrogen, right? Then at the end, remember what we have here is that when we are generating an electrophile, unlike others, because of sulfuric acid, we are having what we have FeBr4, because the extra bromine is what is going to add to the catalyst to have Br4. And now this catalyst has become a nucleophile. So in the presence of first stage, where we are going to take a hydrogen is going to come and going to bond with one bromine that is that in the catalyst, making the catalyst unstable. So that's why we're going to form HBr and the catalyst regenerated. Unlike others, where we are using sulfuric acid to abstract the hydrogens to stabilize as a catalyst. This time around, we are not, because there is no, the catalyst is not sulfuric acid. So the hydrogen is going to bond with the remaining bromine in bromine molecule to regenerate the catalyst. So that is all halogenation. So halogenation reaction is different. What we need is just the halogen and the catalyst. And at the end, the catalyst will be regenerated and hydrogen halide will be formed. Now, another reaction we're going to look at, a very important reaction, is Friedel-Crafts reaction. Friedel-Crafts have 2 types of reactions, which are acylation and acylation. In Friedel-Crafts acylation, we are forming acylated benzene, while acylation, we are going to form a ketone. So that's the difference between the two. Please note it very well. Friedel-Crafts reaction, there are 2 types of reaction, Friedel-Crafts acylation and Friedel-Crafts acylation. So the two are going to use the same catalyst. It's a popular question. What is the catalyst for Friedel-Crafts reaction? The catalyst is aluminum trichloride. Now, using mechanism, remember we are alkylating. So we are adding alkyl to benzene, meaning that the electrophile in Friedel-Crafts alkylation reaction is an alkyl. So using aluminum trichloride as a catalyst, then the alkyl, the nucleophile will be AlCl4. Just like we did in bromination, if the chlorine will also be abstracted to form hydrogen chloride, while my catalyst will be regenerated. So the same mechanism is employed here. The mechanism of halogenation is also employed in Friedel-Crafts reaction because the catalyst does not have sulfuric acid. So we're going to form hydrogen halide as a byproduct and the catalyst being regenerated. So my catalyst is aluminum trichloride and my electrophile is alkyl. Alkyl is a alkane that loses one hydrogen. So that's why it is a substituent. Then remember, we form alkyl benzene. So if it's methyl, we'll call it toluene. So it's alkyl benzene that will form whenever we alkylate it. But in Friedel-Crafts acylation reaction, okay, Friedel-Crafts alkylation reaction has some limitation in the sense of aryl halide and vanillic halide cannot be used as components because they do not form carbocation readily and they give poor yield. So there's so many limitations in Friedel-Crafts because now there's further limitation we are going to see in Friedel-Crafts is rearrangement. So one of the limitation is that some compounds that are aryl halide is when I have aryl is like benzene that has alkylated benzene cannot be used. Remember, is alkylated benzene, and we are using alkylated product. So if my benzene is the alkyl, I cannot use it for my Friedel-Crafts. And when there is presence of electron withdrawing groups, they will also give a poor yield, and it's going to affect limit the reaction from occurring. Another limitation that is very common in this Friedel-Crafts is rearrangements. There's always rearrangements. When primary alkyl halide is being used, there'll be rearrangements, and we are not. So this is some of the limitation. Primary alkyl halide is going to be rearranged, and at the end we are going to form secondary products. So normally the easiest way of alkylating is just methyl chloride. So whenever we are having primary, it's always an issue because there's always skeletal rearrangement. Primary is going to form secondary, secondary is going to form tertiary products. So that's what we talk about poor alkylation. Okay? Poor alkylation occurs in Friedel-Crafts alkylation since the product alkyl benzene is more reactive than the benzene. So whenever we are having this, there's always poor alkylation, polyalkylation. Polyalkylation in the sense that we have more than one product. It's when we are expecting one product, we are going to have more than one product. Whenever there is primary alkyl halide, we are going to have more than one. Why? Because we are having the product more reactive than the reactant because of the presence of electron withdrawing group. So when there is a substituent, depending whether the substituent is donating or withdrawing, it's going to affect the activity of our alkylation reaction. So that's one of the limitations. So limitation of Friedel-Crafts, number one is polyalkylation. And number two is also aryl halide and vanillic halide cannot take part in the reaction. And when there are electron withdrawing groups, they can also give a poor yield. Okay, so these are the limitations of Friedel-Crafts reaction. Then we come to Friedel-Crafts acylation. Remember, acylation is when you're talking about alkyl substituents. Whenever you want to acylate, you're going to talk about SI group to form a ketone. Now, that SI group is COR. Listen, this one is very dicey whenever you're forming the product because whenever you're forming the product, it is the carbon that is going to bond, not the oxygen. Now, the first stage is for us to form the acylium ion, just like we did in alkylation reaction. And remember, it is still the same Lewis acid that is being used as a catalyst. The difference between Friedel-Crafts alkylation and acylation is that in alkylation, we are using alkyl halide, while in acylation, we are using acyl halide. That acyl halide is going to generate acylium ion, which is going to be the electrophile. Now, in that case, the bonding site is a carbon. Don't go and bond to the alkyl. Don't go to bond to oxygen. The bonding site, remember, we are forming ketone. The ketone is a byproduct. In that sense, the bonding side is carbon. Then carbon will connect to oxygen. So whenever you're forming this product, look at the valency of the atoms. Carbon has valency of 2. So when carbon is bonding to itself and bonding to oxygen and then bonding to methyl, we are going to maintain the valency of 4. Then oxygen has valency of 2. So these valencies are maintained. But when you connect oxygen directly to the aromatic ring, you're going to form valency of more than 2. So make sure you understand how this ketone is being formed. It's very, very important. Now, another thing is effect of substituent on benzene ring. Let's see. Effect of substituent on benzene ring. Now, the substituent on benzene ring will make benzene to either be faster or slower. Remember, I said benzene is on its own need to be activated. That's why you're seeing catalyst in the reaction that we've just seen. But when there is a substituent, the substituent can either make the benzene ring faster or slower. Now, when I have methyl, now that's a product of Friedel-Crafts alkylation reaction. When I have, if I'm using methyl chloride as my reactant in alkylation reaction, I'm going to form methyl benzene, which is called toluene. Now, this is another thing again. When you are in an exam and you see methyl benzene and you see toluene, the most correct form is toluene. Because when there is methyl in benzene, it has a common name called toluene. So toluene is more accurate if you're having option of name the compound and you saw methyl on benzene. Don't go and give it name to be methyl benzene if you have toluene. Toluene is more accurate. But in absence of toluene, methyl benzene can go. I hope we are getting all this. Then this toluene is going to react faster than benzene. Why? Because the methyl in that is electron donating. Now, let me make something clear to you. When you're donating, like if you have a friend that is always giving you, the friend will always making you happy because you know that whenever you go, the friend will release. It's activating. That activation is making you happy. And when you get alert, you are smiling because it is credit alert. But when you get debit alert, you're not happy. Whenever the alert is debit, you just delete it. Then if it's credit, you're going to smile. Now, when there is donation into your life, you are activated. And that activated, your mood is better. So that's what happened in benzene. So when the electron donating group in benzene, the ring is activated. Right? And when it's activated, it makes the reaction faster. So electron donating ring has an activates benzene ring and make it faster. And these electron donating groups are octopara directing. They are octopara directing. You can see that it only makes benzene to react 20 times faster than it makes toluene to react 20 faster than benzene in nitration reaction. What does it mean? When we are doing our nitration reaction, we are using catalysts. because benzene is not very active. Then when I see methyl or that benzene, presence of that methyl is going to release electron, is going to make the reaction to be faster than normal benzene. So toluene reacts faster than benzene because of presence of methyl, making it electron donating. Now, and what is autopara? If you remember, when we are starting this class, we said that the isomer of disubstituted is auto meta para. Now, let me give you the answer to that question. When I'm talking about 1,2 disubstituted, if you remember in the first class, I said we have only 1,2 disubstituted because when you number the ring of benzene, we have 6. And I said 1, 2, and 1, 6 are the same. And that is the 1,2 disubstituted. That is a question that confuses students very well. When they hear about 1,2 disubstituted, they say it's the isomer auto meta para. No. 1,2 disubstituted is talking about auto position. How many isomers do we have in auto position? Remember, we have 1 auto, we have 1 meta, we have 1 para. If the question says how many isomers do we have in 1,3 disubstituted benzene, it is 1. 1,4 is 1. All of them are 1, 1 because position 1, 2, and 1, 6 is the same thing. So that is auto position. So it's only 1 isomer. So whenever we are having electron donating on benzene, so if I have like methyl on carbon number 1 on benzene, any substituent coming can either go to 2 or 4 because electron donating are auto para directing. It means that the incoming substituent. Now I want to do nitration. Let me see the next slide. Okay, this is the example. Now I want to do nitration and I want to use toluene for my nitration. Remember, when I was nitrating benzene, I don't need anything auto para because benzene does not have any substituent. But because toluene now is benzene that have substituents on it. So if this substituent is going to tell us anything coming, where they're going to go. I'm in class. So because of this toluene is electron donating, whenever a substituent is coming, like NO2, because I'm nitrating. Now look at this reaction. You can see my reaction of nitration of toluene now. I don't need any conch because the toluene is already activated. I don't need anything, any conch to make it to react. That's why I will use normal sulfuric acid. Now, in that case, I need the upcoming substituent is going to go to position number 2 or 4 because toluene is auto para directing. Toluene is auto para directing because the rings are already activated. Now, but if what I have, we are going to go, well, if what I have is electron withdrawing, it will go to meta position. So electron donating goes auto para, while electron withdrawing go to meta position. NO2, we are going to see in other slide, is electron withdrawing. So when they come, they're going to direct any substituent in carbon in position number 3. So that is effect of substituents in reaction. So whenever there is an effect of substituents, you talk about where would the incoming position substituent be? Where would they be placed? So the nature of the substituent that is attached to the benzene ring will determine the position of the incoming substituent. Let's continue. Now, when I have nitrobenzene, right? If I'm having, like I said, if in place of methyl I have NO2, it is nitrobenzene. Because NO2 is electron withdrawing, the incoming substituent is going to position number 3 because they are deactivators and they are meta directors. So activators are auto para, while deactivators are meta directors. Activators are electron donating, while deactivators are electron withdrawing. Activators make reaction faster, while deactivators slows reaction. So that is what you should understand when you're talking about effect of substituents on benzene ring. They can either activate the ring or they deactivate the ring. When there is deactivation, there is slower reaction. When there is activation, there is faster reaction. And activators are auto-para-directing, while deactivators are meta-directors. So look at the substituent that can activate and look at substituent that can deactivate. But there's something that we need to understand, that my halogens are deactivators, but they're auto-para-directing. Please don't forget this. These are one of the questions. These are very common questions. So go and study effect of substituent on benzene ring, because you must not miss it. Right? Remember, it's a CBT. So I don't know whether the question should go up to 40 questions or 50. So I think that each of the topics, there must be something you must know about it. So this one I'm talking about, make sure you understand it. Now, activators are auto-para-directors. We have strong activators, we have moderate, and we have weak activators. Alkyl substituents are the weak activators. Amine derivatives and hydroxy group are the strong activators. That's why phenol is a very strong acid. Now, these are meta directors, which are the activators. Remember, the activator, the common one you should know is about NO2. Then your carbonyl compound is sulfonic acid, your ester, your carboxylic acid, your cyanide, they are tertiary amine. They are all the activators. They are meta directors. So whenever I see these ones on the top of benzene ring, if they're the only substituent on benzene ring, anything coming, they will push it to meta position. But when I have halogen, so if I have bromobenzene as my compound, and there is a reagent coming, like I want to nitrate bromobenzene, where will the upcoming substituent be? Because this bromobenzene, they are the activators. But the thing is that though they are going to make the reaction slower, they are auto-para-directing, meaning that any substituent on halobenzene must go to position 2 or position 4. Why? So halogen are in the middle, they are auto-para-directing, and they are the activators. So they are the ones that occupy a unique position. They share with auto-para-directing. Normally, by virtue of auto-para-directing, they're supposed to be activators, but rather they are still the activators. Why auto-para-directing? So make sure you note it. Halogens are the activators, but they're auto-para-directing. So because a question like that must come. So if you don't understand it, you will get yourself confused. So the activators are supposed to be meta-directors. No, halogens are occupying a middle position. They are auto-para-directing, and they are still deactivators. So understand the effect of substituent on your benzene ring. So whenever you see benzene ring and there is a substituent and a reaction is occurring, where the position of the product of this reaction will determine the nature of the reactant or of the substituent on the benzene ring. If they are activators, they will go to auto-para-directing. But if they are halogens, they will also make the reaction slower, but they will be auto-para-directing. So if they will tell you which of the following will be more reactive. Halogens, bromobenzene is not as strong as phenol because the activator slows the reaction. So which of them will make the reaction faster? Then look for the activators. They are going to make reaction faster. Or which of the following are not auto-para-directing? Don't go and choose halogen. And they can tell you which of the following is auto-para-directing, yet the activators. Please understand all these questions.
Please come again.
Okay.
Please come again.
It's not clear about the halogen stuff.
Halogens are occupying a dual position. Normally, all auto-para-directors are activators. But halogens are deactivators, yet auto-para-directing. So they are occupying dual position, they are auto-para-directing, and unlike auto-para-directing, they are deactivators. So if you're talking about deactivators, halogen is there. And if you're talking about auto-para-directors, halogen is there. Do you understand?
Can also be an activator and a deactivator.
Halogen is not an activator. Halogen is the activator, but they're auto-para-direct.
Okay,
it means that they are like they are auto-para-directing, But by being auto-para directing, they're supposed to be activators, but they're deactivators. So they're like in the middle. They are taken from auto-para directors. They're also taken from meta directors by being deactivators.
Okay, ma.
Do you understand? So halogen is one that is benefiting from both two. I want to be rich, and I don't want to die young. Because if you're Yahoo, you are going to be rich, but you're going to die young. So you cannot say, I want to be rich, I don't want to die young. It's not possible. So that's what halogen is saying. I want to go and make money fast, but I don't want to die young. So they're auto-para directors, and they're also deactivators. So when you have a question and say, which of the following are deactivators? Halogen is part of it. And if they say, which of the following are auto-para directors? Halogen is part of it. So a question can say, which of the following substituent is both activators, is both auto-para directing and the activators. Make sure there are halogen. If there is halogen, choose halogen. Don't say because the activator, they're supposed to be either a carbonyl compound or ester or carboxylic acid, because they are meta directors. No. The only meta directors we have, all meta directors are deactivating. But halogen is only auto-para directing that is a deactivator. Please note that. I would have wanted you guys to, I think some student came to my office and I gave them a past question. Please snap that past question and share on the group. Snap it and share on the group. I want to see them on the group today. The essence is that so you can have a hands-on on the likely question. And people that are on the mentoring team, we are going to be having question and answer time once in a week from January. Though you decide and tell me the time that will be convenient for you, so you can understand how questions are asked. Because at times we are very, very confident that we'll make mistakes, we mobile things up. The essence is that to help you, especially people that are in science, in biological sciences and marine, they are afraid of chemistry. So I want to also encourage you not to be afraid of chemistry at any cost. Chemistry is very simple, but to understand it, that's the essence of being in the class. Your exam is CBT, yes. Your exam is CBT. So that's why I'm explaining to you, because CBT is the most difficult exam, easy to pass and easy to fail, because as soon as you pick A, is A. And I don't know whether you're always given opportunity to go back. So that's why you have to be careful to choose. And when you enter exam hall, make sure you take a deep breath in and out. Calm yourself down. Don't be in a haste, so you don't go and mobile things up. So let's continue.
Yeah, please excuse me, ma. For the mentoring class, how can we be part?
Well, after I'm going to share the link for you.
Okay, thank you, ma.
Excuse me, ma. What do deactivators do exactly?
Deactivators close the reaction. Deactivators they reduce electron density.
Okay, thank you very much.
So
okay, ma, please excuse just one more. Ma, how can we recognize those elements that are activating in auto-para and that are also deactivating in meta? Because you said for the deactivators in auto-para, they are halogen. So like I need names so I can be able to recognize the element there.
What are the halogens? Are you not looking at the slide? All the halogens are auto-para, they are deactivators.
Yes, I know that. Like I'm saying, like I just want to know the names. Like you said, halogen for auto-para directors. So what are the elements in meta deactivators called and other?
Now look at the meta directors. I said NO2 is the most common meta directors. Then you can see tertiary amine, right?
Yes, ma.
Then you can see cyanide, you can see carboxylic. So if I have benzoic acid as a compound, any compound coming in is meta directing. If I see cyanide on top of benzene, any compound coming is metal directing. So if I see any of these compound, any of these substituents on top of benzene, if I see an ester, a benzene that have ester as a substituent, then others are metal directing. Do you understand? If I see benzaldehyde or like a Friedel-Crafts reaction that form a ketone, every other thing is metal directing. Sulfonic acid, benzene sulfonic acid is metal directing. So when I see all these substituents on top of benzene ring, and what it means is that if I have a benzene and on top of benzene I have NO2 and I want to halogenate, I want to brominate. Listen, I want to brominate. Remember, in bromination reaction, I'm going to use bromine molecule and catalyst, right? I hope you're seeing the reaction I'm writing on N. Now, because I have NO2 on top of a benzene ring, now what is taking charge now is that NO2. So my halogen, my bromination will go on position number 3. Do you understand what I'm saying? If I have NO2 on benzene ring, that's nitrobenzene, is the reactant. And I want to brominate nitrobenzene. Question is that where will my bromine be? Which position will my bromine be? Will it be position 2, 3, or 4? Because NO2 is metal directing, my bromine will go to position number 3. But if I have something like bromobenzene as my reactant, and I want to nitrate, nitration is nitric acid and sulfuric acid. Now, where will my NO2 go? Now, because my halogen, they are deactivators, but they're auto-para directing, I'm going to have two products, either auto-nitrobenzene or para-nitro substituent. So my NO2 will be either auto or para, because halobromine is auto-para directors, though they are deactivators. It means that those are going to make the reaction slow. So it means that I need an acid, a conc sulfuric acid, conc nitric acid to make the reaction occur, because they're already weak. Do you understand? They make reaction weak. Deactivators are people that make reaction weak. A deactivator is that your friend that whenever he comes to you, he will always tell you problem. Everything is negative, negative, negative. So that they are deactivators. Activators are people that come and tell you that when you're feeling down, they say, you can do it. This is simple, we can do it. They make it to be alive. They ginger you. They are activators. So the activators neutralize it, make the reaction slow, while activators make the reaction faster. So whenever you see a substituent on benzene, so the upcoming ones, this substituent will direct it where it's supposed to stay. So if it's a substituent that are deactivators, then they're going to take any other thing to position number 3. They only have one position. That is why anybody that is negative around you have only one thing to do, to demoralize you and to bring you down. They don't have any two. Right? So in activator, there are some people that can make you to be very active. There are some people that will make you to just feel okay. There are some people that whenever they come, even if you're on 0 level, you go to 120 level. They are strong activators. Some are just moderate. They'll make you to be fine. But some will just make you to be okay. So that we have 3 levels of activating. Okay. Now, by inductive effects, when look at this arrow, wherever I see arrow going up, if you're talking about releasing. This one, they're increasing electron density. The other one is decreasing electron density. So all activators like methyl are donating electron. They're going to increase electron density. Anybody that makes your account to be increased is making you happy. But whenever you're having debit, you're not happy because your electron density, which is your money in the account, is reducing. So they are the activators. So activators increase electron density, while the activators reduces electron density. So that's what they do. So by virtue of inductive effect and resonance is very, very important. The balance of inductive effect and resonance. Remember, because of the benzene ring, we are talking about resonance. Inductive effect is because of the effect of electron withdrawing and donating by inductive effect. So the group attached interacts with the electronic structure of the ring in such a way that the autopolar position acquire a partial negative or partial positive charge. This can easily be understood by resonance theory. Whenever we are doing the mechanism of benzene, when the movement of the arrow, you talk about the resonance. This because when electrophile attack, there's always a partial positive. Now, if you look at that partial positive center, you realize that in auto para position. Then whenever I think there's a way you're going to go, you're going to get negative on a meta position. I don't know whether that okay. Let's look at this is what I'm saying now. Look at the mechanism we are talking about now. Now, because of the presence of, remember when we are doing the one of benzene, what we are having is we have positive center that we are releasing electrons to neutralize to form another bond. But this is another mechanism entirely. Because we have a substituent which is donating electron. When it donates electron, becomes electron rich. That negative center means electron rich. And the person donating alone, because there is lump of electron on nitrogen, nitrogen is going to donate the electron. That's why the electron donors. They have lone pair. Then when they donate that electron, now the single bond forms double bond. And remember, two double bonds cannot be because conjugation must be maintained. So as the new bond is formed, another one is going to be broken. And look at where we're having a negative center. Right? Now, if you look at the whole scenario, you can realize that we have negative center at auto position and meta position and para position. That is why amine it's auto para directing. Because what we're adding is electrophile. And electrophile is a positive species. So my electrophile can either be on position number 1, position number 6, which are the same thing. 1 and 6 are the same thing, right? Our position number 4. So that's why they are auto para directors. Because they're electron donors. When we are going to talk about, this is by resonance hybrid. Resonance hybrid. Remember, benzene has to do with resonance. Right? Okay. Then do you understand this slide? Do you understand this slide before I move?
No.
I don't get, ma.
Now, do you understand the first slide we did when we were talking about benzene and mechanism?
Yes, ma'am.
Now, in this same manner, remember in that benzene, there is no substituent. But in this one, there is a substituent. And remember, this substituent is electron donors because they have lump of electron. Now, because of that lump of electron on nitrogen, it's going to release it to the ring, making the ring electron rich, richer than it was. Because double bond means electron rich. So when there is addition of a lump of electron, there is high electron rich. So when that bond is coming, lump of electron is coming on from nitrogen to the bond on benzene is going to break because the two bonds cannot stay, right? You know why they cannot stay? Because we are talking about conjugation. We cannot have two double bonds together. It becomes isolated. Okay? So now we cannot have these two bonds together. These two bonds cannot be together. So as one bond is being created, another bond is going to be broken. Now, remember I said, now the bond, where the bond is leaving from nitrogen, is going to release positive center. Like I told you, when a bond is moving from, is releasing positive, where it's moving towards is releasing negative. Now, because this nitrogen is releasing electron, it's going to be positive because whenever you're giving somebody money, you're positive to you because it's credit to you. The person collecting is negative because the person is owing you. So that's what is happening. Now, because this bond is coming, it's going to deposit a negative center. And this bond is going to break again. The one breaking is leaving behind a positive center. That's why a new bond is formed. A negative center is created. Do you understand that story now?
Ma, please, I have a question.
Okay.
The third diagram, the negative charge is on the meta position. Is it that third diagram is not
No,
stable?
it's not. It's on meta. It's on para.
The third diagram.
Yes. The third diagram one is on auto. It's not on meta. Meta is position 3.
Oh yeah. Thank you.
I said 1 and 6 are the same. That's why we have only one disubstituted benzene, because 1 and 6 are the same thing. So we have position 1 and 6, which is the same thing, right? So now that's where it goes. So whenever a bond is broken, we have positive and negative. Where the bond is moving to is depositing negative. Where it's moving away from is depositing positive. So because we follow that scenario, we are going to continue. Now what happened is that this second reaction is this other bond that is remaining is going to break again to deposit negative behind, in front, and leave positive behind. That's why we're going to form a new bond. So the process continues. What I would have wanted you to learn is that now when this bond is broken, right, it's going to deposit negative. Leave that where the arrow is going. Let me tell you how it will be easy for you. Look at the other bond that is still there. Break that bond again. If you break that bond again, behind you is positive, right? Then when positive and negative meet, new bond is formed. So in front of you is another negative. So neglect that negative, go to that other bond that is formed, break it again. You're forming negative in front. Behind it is a positive. So another bond is formed. So that's how bond is formed. So go to the bond that is not broken. Break it. The way your arrow is moving, if it's where your arrow is moving to is depositing negative, where it's moving away from is going to deposit positive. So when there is negative and positive centers, a new bond is formed. Because when you break a bond, you're going to form positive and negative species. So that is the way it's formed. I wish there's a practical physical class I would have talked to them. But this one, nobody will ask you this in the exam. But in your higher class as a chemist, you're going to know about this when you're talking about reaction mechanism in 322. So for the sake of
I have
exam,
a question, ma.
but for the sake of exam, know that because we have electron rich, this amine is going to release the electron, and at the end we're going to have auto and para position. That is where electrophile will come and attack. That's why they are auto para directors. We're talking about mechanism of auto para directors. That's what we're talking about here. Question.
Hello, ma. Sorry, ma. Is there any how you could help us use your cursor to identify what you're talking about?
Oh, seriously. I think maybe I was thinking I will finish today. Since I'm not finishing today, in the next class, but the next class cannot be on Monday. Monday is my birthday, so I'm not going to have any class again.
Happy birthday in advance.
Happy birthday in advance.
Happy birthday in
We
advance,
celebrate
ma.
you,
Happy
ma.
birthday in advance, ma.
Another thing or if it's possible, you guys cannot have time within the weekend. So thank you. If it's possible within the weekend, if you can have time so that we can trash this, so we know we are done with this.
No problem, ma.
Okay, so if you agree on that, go to the general platform and tell me the date. Thank you very much. So
Thank you, ma.
yeah. So now I wanted to see if it's possible for me to employ a whiteboard to make this clear for you guys. So I don't know. I have to learn how to use that whiteboard to teach you this particular thing. Okay, but I will look a list of making it work so you can understand it. But as long as this CBT is concerned, you don't need to know all those mechanisms. You need the mechanism for chemistry students that will do more of chemistry. Okay. So, but know that for your CBT exam, I want you to understand that my present alanine. Now, whenever you see a reaction, whenever you see a compound, benzene that has amine as substituent, it has a common name. Don't call it aminobenzene. It's better called aniline. So, that's some of the questions you might see. You can see it says this is the amino group, it's my aminobenzene. Don't call it aminobenzene. The more accurate one is aniline. So when I see methyl on benzene, don't call it methyl benzene, you call it toluene. So those ones that have a common name, don't call them their the name, the derived name. Use the general name. So it's much more accurate to call this compound amylene than calling it aminobenzene. Hey, don't worry. I'm celebrating in my house and in the church. So any question on this, because of our time, I don't want to rush this. This is a lot. I don't want to rush it for you. We still have so
All
much
right.
to do.
I have a question.
Okay? So let's ask questions so that we can have another class to tidy this up.
Excuse me, I have a question.
Okay.
Okay.
Okay, sorry, before your question, let me quickly
Yes, boss.
chip in this. Okay, look at this NO2. Look at where we are having our substituents. You can see in position of 2 and 4 is positive, right? Meaning that nothing electrophile cannot attack in 2 and 4 here. Unlike when we are talking about amine, a position of 2 and 4 is negative. Remember, you're doing electrophilic. So electrophile can attack them. And that is why NO2 is only metal directors. Okay? Because there are positive charge on autopolar position, thereby inhibiting electrophilic attack at this position. But it can occur slowly at meta position. That's why they are deactivators. So I just want to keep it to you so you can ask your question. So these are the opposite. When you're reading it, make sure you go back and read the slides, please. When you can understand, when you read the wordings, the explanations before the mechanism, you will understand it better. And if you don't understand, you can ask questions in the next class. So ask your question.
Okay, Ma, for the products of like when we have the products of auto and para directors, basically. So I was wondering if, because you wrote something like 60%, 40%, yes, 60%, 40%. Is it that like the probability of the one with auto is 60, while that of what's the name, para is 40, or the both of them will be formed together?
Yes. Because para is much more stable. At times, some of those percentages determined in the laboratory, all right? So when it's being synthesized, the yield is more. So the one that have higher percentage is the one that have higher yield in the laboratory. So nobody asks about that. That's from synthesis. Yes. So let's ask our questions. I know this is a lot. Just ask your question. In the next class, I'm going to try to just make sure the essence of the group is for you to ask questions. If there's any question that you're not, both in mentoring and general class, I'll answer your questions. Okay? If you have any question that you don't understand, why I say you should ask on the group, because there are some people that are on the same group that don't understand. Some people are shy from asking questions. So when others ask, they will learn from it. So when you private chat on question, others do not know the question, is not good. Just make sure you ask your question on the general platform or mentoring platform so people can learn. Okay? So when I see the question, so that's why I am going to make that, I'm going to lock up that group so that if you're asking questions, I will not come up, I will not see the question again. So the question can always be visible. So ask your question, but whenever you're reading, whenever I'm in the class, I'll try as much as possible to tell you how to read for your CBT. The way to read for CBT is different from the way you read your theory. So in your CBT, don't bother yourself about mechanism, but understand the nitty-gritty of mechanism. But nobody will tell you to start drawing structures in CBT. So when you see amino group, you understand that it has lone pair of electron. That's why it can donate. And the one that don't have, that's why they can withdraw. So when we're talking about this, we employ inductive effect and resonance. So some of this, I don't know whether they've talked about inductive effect. Make sure you know what is inductive effect. Make sure you understand resonance. These are very questions you must be asked. Understand what happened in resonance. Understand what happened in inductive effect. So I'm going to create some questions, even on the one I'm teaching now and the one I do not teach. Okay? By virtue of the YouTube channel, I'm going to create that questions, and we're going to have questions weekly by weekly, so that when exam comes, the people that did last year, we started late. And because of that, some of them that joined late did not meet up, but people that followed, Some were having 90-something%, some are having 80-something%. So they're very good news. So why I'm telling this is because I want to encourage you that this is a doable thing. Some people in biological science, they will tell you some of them that, and you have somebody in biology that has 92 or 95. So don't say because you're not in chemistry, this is chemistry. No, it's a doable thing. It's the simplest of chemistry. I'm making it CBT, make it more simple. Because you don't need to come and start drawing structure and you make mistake. Maybe your benzene will start flying and they say this is not benzene. So just read and read with confidence, okay? At the end, we're going to smile. And you're going to come and tell me that, I was afraid, but I have 80. I was afraid, but I have 90. I was afraid, even people that cannot pass, that will fail, will just have C. But I don't want anybody that is in my mentoring team, especially to have C. We should be dancing with A and B. And the A I want, anybody that will have 98, I'm going to give the person gift.
Wow.
So I challenge you, even if you're 20 that have 98, you get gift from me.
Thank you, ma.
Okay.
Please, ma,
Please
can we ask
don't forget to add the link, ma.
Okay. All right. So
hello,
I think
ma.
Hello, I can hear you.
Please, ma, can we ask you questions on other topics?
Of course you can. You can.
All right, thank you. Thank you.
Ask. Yeah. So any topic that you feel that they've treated that you don't understand, and that's the essence of the YouTube channel. That YouTube channel, I recorded all the lectures. If there are 100 topics, I recorded 95. So that 95 is enough for you to get your A. So even this one I'm teaching you now is on the channel. So on your own time, when you know you don't have anything, you're tired of reading, go and listen to those topics again on YouTube channel. Listen to them again. And then you're going to, remember when you listen to something all over and all over again, they become part of you unconsciously. That's why you can sing a song without even knowing the lyrics. So that's the essence of that channel. So that you can always listen to them, listen to things that are people that are having issues, listen to that topic that is disturbing you. Listen there all over and all over again. You can even download and listen. Okay? So that they become part of you. When you enter exam hall, it will be like classwork. And whenever you're giving assignment, try to do it yourself. Don't copy from anybody. It's better you fail in the class and you take correction and pass in exam than copying and copying. When you enter exam, you realize that there's nothing upstairs. So your 98% is sure. Just keep doing what we are talking about. Okay. I wish you success. So do you have?
Thank you, ma.
Bye for now. So if you want us to have class this weekend, let me know. And if you don't want it to be next week Thursday, let me know too.
And ma, also please don't let our question be based on what you're teaching us in class.
Of course, anything we teach you in class, what we're going to say. Because nobody is interested in studying.
And it should be direct. It should be direct.
I'm not the only one that will set question. Everybody has to set question based on what so anything I'm telling you in the class, anything I'm telling you in this online class, you should be mindful of. On all the assignments I'm giving you, my questions cannot be missing from them. Nobody. It's not a thing of joy that people are coming to repeat because it's going to be much more workload. So we don't need it. Okay.
Thank you.
So
thank you, ma.
Make sure you do your part. I wish you success. So let me know when you want to have the class.
Ma, I want to have the class.
We want to have the class. Yes, we want to have the class.
Let's go and discuss.
Next week Monday, ma.
Discuss
it on the group, Joe.
Apart from Monday is fine by me.
Just decide and let you know, ma.
Okay.
We have other busy schedule. We have other classes. So, ma, we'll discuss and let you know.
Yeah, just discuss and let me know, okay? All right. Bye for now. I'm ending the classes. Bye.
Assignment.
Thank you, ma. Thank you, ma. Happy birthday in advance.
Thank you. Who said assignment?
And happy birthday in advance, ma.
Thank you. I'm going to send the assignment to the class.
Our cake, ma.
Okay. You also class now. Just now. Do you have class like now?
Yes, now we have class.
Yes, now.
Now, okay. So I will draft the assignment and I'll draft the assignment and I have somebody that is helping me. The person is going to help me. We're going to put it on Google Form. They will share the Google Form for you to go and view. So every assignment should be submitted on Google Form. But please don't use AI. Don't use your Google. Use your slides. So when I give you assignment, go back to those slides. Everything is in the slide. It will help you to read those slides better and understand better. So you can understand before you write the assignment. Don't go and copy. So this time around, I'm going to give you a longer time. Or from now till or throughout the weekend, you're going to have time for your assignment. So as soon as the assignment drops, go back, view it. If you cannot do it immediately, go and read and go back to it again. Okay? All right. Bye for now.